to the video tutorial series of the mobile computing and wireless communication. I am your instructor Varsha Tar. Let's start our lecture series. So topics to be covered in today's lecture, that is fading. Okay, till now we have discussed this term so many times. Okay, fading may occur, fading can happen. So exactly what is the meaning of this fading? Fading, that means what? Any unwanted signal, disturbance in signals, so that is known as fading. For example, you are going to park your vehicles in a basement and you are continue listening the radio channels, but when you are moving towards the basement, the lower basement, so at that time you are not able to receive that particular signals, so that is what a fading. Okay, you are not going to receive the signals exactly that is going to be transmitted, so that is what interference in the signals, so that is known as the fading. Now all of you aware about what is fading? Fading, that means what? The unwanted signal or disturbance in signal, that is known as fading. So here you can see fading is used to explain the quick changes or fluctuations in the amplitudes, frequency or phase of the signals over the short period of time. Okay, short period of time, there is a fluctuation in signal. For example, sometimes there is a high spike in TV volume or in a radio volume. So that is high spike is known as also fading. Okay, so that is a noise disturbance, any disturbance, any unwanted signal that we don't want. Okay, due to effect of the multipath signal, the multipath signals combines at the receiver will vary in amplitude and phase depending upon the distributions of the intensity, so relative propagations times of the waves and the bandwidth of the transmitted signals. As we have seen what is the multipath effect in the previous lecture, so that multipath effect will define the fading. Why? Because signals are transmitting with the same intensity. With the same intensity, they are not going to receive at the receiver side. They will change in the phases, they have changed in the intensity, etc. So this is known as fading. Okay, in wireless communication, it is a variations of the attenuation of the signal with the various variables like time, geographical positions, and the radio frequency. So that all that is known as the fading. Here you can see this is the signal. Okay, this is one signal that is and that signals is because of the distance loss, it loses its intensity. Then this pink color is showing it is a shadowing, and red color showing it is a multipath fading. So this different kinds of effect will be there on this signal, so that is known as the fading. Now before starting the fading, let's learn about the some term. So first term is a coherence bandwidth. So what is coherence bandwidth? It is a statistical measures of the ranges of the frequency, that is known as the coherence bandwidth. Okay, over which two frequencies, that is a channel, can be considered approximate the maximum bandwidth, or the frequency interval over which two frequencies of the signals are likely to experience the comparable or the correlated amplitude fading. So that is what the coherence bandwidth. We can say the statistical measurement that is defined as a range of frequency that is used to transmit the data, that is known as the coherence bandwidth. Now next term is what? Delay spread. Now what is delay spread? It is a measure of the multipath richness of the communication channel, difference in the received at the transmitted signal in the multipath channel. That means with the signals that will be transmitted, that will not be received by the receiver with the same intensity, with the same phases. There are change in the signal, there are change in the time duration. That exact time duration, that is 25, for example 5 seconds, so signals will reach in the 7 seconds, so that is what the delay spread. Okay, Doppler shift. What is Doppler shift? The frequency shift at the receiver in a multipath channel is referred as a Doppler shift. Okay, sometimes it may be possible that your device will come near to this antenna and it will move fast to fast far away from the antenna, so that frequency will be changed. Okay, so that change in a frequency will be known as the Doppler shift. Then next is what? RMS delay spread. It is a root mean square value of the delay spread. Okay, so root mean square value that of delay spread, that is known as the RMS delay. Got it? So these are the terms that is going to be used in the fading. Now, fading has a two types, which are small scale fading and large scale fading. Small scale fading for the short distance and large scale fading for the long distance. But we cannot measure the large scale fading. So we just will discuss about the small scale fading. We cannot calculate the fading on the large distance. So that's why we just consider the small scale fading. Okay, for the small scale fading, you can say based on the multipath time delay spread. Now all of you aware about the delay spread. Okay, so based on the multipath time delay spread, we have two types of fading, which are flat fading and frequency selective fading. Then based on the Doppler spread, okay, as your device is coming towards to the base stations and moving far away from the base station. So based on that, the change, there is a change in frequency. So based on that Doppler spread, we have two types, which are fast fading and slow fading. Okay, it will come towards to the your antenna, then it is a fast fading, come go far away from the antenna, then that will be a slow fading. Okay, so first of all, what is flat fading? Such types of fading occur when the bandwidth of the transmitted signal is less than the coherence bandwidth of the channel. Okay, so fading occur when the bandwidth of the transmitted signal is less than the coherence bandwidth. So at that time, flat fading will occur. Okay, equivalently, if the symbol period of the signal is more than the RMS delay spread of the channel, then the fading will be the flat fade. Okay, symbol period, that means the time that is exactly will used to transmit that particular signal. But the symbol period is more. Symbol period is more. That means it will take more time than RMS delay spread. So at that time, the flat fading will occur. So here you can see when such type of situation is there, so at that time flat fading will occur. Here in this orange color, that is your coherence bandwidth, and this in a green color, that is your entire signal. So at that time this flat fading can occur. So we can say that the fading occur when the BS is less than BC, where BS is the signal bandwidth and BC is the coherence bandwidth. Okay, so when it is less than the coherence bandwidth, at that time it can happen. And then we can say the TS is greater than sigma R. TS is what? The symbol period is greater than the root mean delay spread. So at that time also this type of spreading can occur. That means when signal will take more time than the defined time, then this flat fading will occur. Now next is the frequency selective fading. What is frequency selective fading? Frequency selective fading can occur when the signal bandwidth is more than the coherence bandwidth. Okay, we have the signal bandwidth more than the coherence bandwidth. At that time, flat fading will occur. Okay, bandwidth of the mobile radio channel or the equivalent to the symbol durations of the signal is less than the RMS delay spread. So at that time also this frequency selective fading will occur. So here you can see in this figure, you have the bandwidth of your signal that is much more than the coherence bandwidth. So at that time, the signals that have the same intensity, same frequency, that will be easily passed through that channel. But the signal with the high intensity, with high frequency, may be possible that they will be affected by the noise, because your coherence bandwidth is less. That's why. And same way, BS is greater than BC and TS is less than the sigma R. That means symbol period is less than the root delay square. At that time, this fading can occur. Now next is a fast fading. Okay, in fast fading channel, the channel impulse responses change rapidly within the symbol duration signals. That means the intense bandwidth is same, but the moving capacity is very fast. So at that time, this type of fading can happen due to Doppler shift. Okay, Doppler spreading signal undergoes the frequency dispersions leading to the distortion. So therefore the signal undergoes in the fast fading. So symbol period is greater than this coherence bandwidth. So at that time such type of fading can occur. Where TC is the coherence times and BS greater than BD. That means where BD is the Doppler spread. So bandwidth of the signal is greater than the bandwidth of the Doppler spread. So at that time, such type of fading can occur. Slow fading, that is exactly reverse of the fast fading. In such channel, the rate of the change of the channel impulse response is much less than the transmitted signal. Okay, so we can consider the slow fade channel as a channel in which the channel is almost constant over at least one symbol period. So we can say TS is less than TC and BS is greater than BD. So when such type of situation is there, we have the slow fading. Got it? So summary of this lecture, we have learned about the different types of fading. Okay, fast fading, slow fading, frequency selective fading, etc. Okay, so fading, that means what? Any unwanted signal, disturbance in noise, disturbance in your signal, interference in your signals, noise, that unwanted noise in your signal. So that is defined as fading. Okay, and we have seen some basic terms like coherence bandwidth, root mean square, delay spread, Doppler spread is what likewise. Okay, so remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.